So let's see if this really is an ellipse. So we have to separate out the x's and the y's here to try and put it in standard form. So to do that, we have to complete the square. So first thing I'm going to do is I'm just going to get the x's together and the y's together. So we're going to have a 4x squared minus 16x. I'll leave a little space. Switch colors maybe. And then what do we have? Plus 25y squared plus 100y. And then leave a little space. I'm going to put in equals, and then I think I'm going to throw the 16 on the other side. So that would be a minus 16, and we need to complete the square for x and y here. So I'm just going to do that down here for x. So I have my 4x squared. Switch colors. Let's be color coordinated today. 4x squared minus 16x. Put the equals there and ignore the other side for a moment. So to complete the square, we need this to be a 1x squared, so we have to factor out the 4. So we're going to write 4 parentheses x squared minus, and then 4 goes into 16 4 times. And then we're going to put a parentheses, put the equals back in. Now for this to be a perfect square here, I need to take that 4, so that's my b. Not the b we use for an ellipse, they're using p and q, fortunately. And I need to cut it in half. So that would be negative 4 over 2 would be negative 2, and then we need to square that. So that would be positive 4. So then I need to have a plus 4 here for this inside to be a perfect square. So that right there is going to be the square of x minus 2. Now, to adjust this, I got to put something on the other side to balance that 4 I put there. Now, that's not really just a 4. That's really a 4 times 4 right there. 4 times 4 is 16. So I really added a 16 on this side. So that means I got to subtract a 16 on the other side if I want this side to be a perfect square. So bringing that back up here, to make this a perfect square, I need to add a 16 right there, right? 4 times 4. So that means I need to subtract a 16 on that side. This right here, according to my work below, becomes 4 times x minus 2 squared. Now we're going to do the same thing for the y stuff. So for the y stuff, we've got 25y squared plus 100 y, and then equals, we're going to just leave that blank for a moment. I need to pull out the 25. Gives me a y squared. 25 goes into 104 times. I leave some space. And then same idea here. In this case, my b is 4. I need to know what b over 2 is. That's 2. And then I need to square that b over 2, which is 4. So I want a plus 4 here. Now that's really a 25 times 4. 25 times 4 is 100, so I really added 100 on this side, so I have to subtract 100 on that side. This right here becomes the square of x plus 2, and we get the 25 showing up front. So completing that up here, for this blue thing here to be a perfect square, I need to add 100 on that side, and then ooh, I lied here. Let's see. I'm adding 16 on this side, so balance, add 16 on that side. There we go. Add 100 on this side to be balanced. We also have to add 100 on that side. There we go. And then here, I refactored this right here as a perfect square. It is 25 parentheses x plus 2 squared, and these are connected by addition. On the other side, we get negative 16 plus 16 is 0, plus 100 is 100. And then to solve this, we're going to have to divide by the 4 and divide by the 25 to get it in this standard form here. So we have to take everything here and divide by 4 times 25, divide by 4 times 25, divide by 4 times 25. 4 times 25 is 100, so that's 1. On this side, the 25s divide, so I get x plus 2 squared over 4 is really 2 squared. And then here, the 4s divide out, x minus 2 squared over 25, which is 5 squared. So this came out nice. So I'm getting the h is 2 on my version. The k is a negative 2, because notice it says minus k. I have a plus 2, so that had to be a negative 2 for that to work out. And then p under the x is a 5 squared, or 5. And then the q squared is 2 squared, so q is 2. So how do we check to make sure we got that right besides pushing the check my answer button? We're going to graph the original and see if it matches our new version. So let's get our calculator out and check to see if we got it right. All right, so the original was, make sure I got it right, yep, 4x squared plus 25y squared minus 16x plus 100y plus 16 equals 0. Okay, so we can see that is an ellipse. And it looks like that ellipse is centered at 2, -2, so that looks good. So just some other checks I can make along the way is if I graph x equals 2, I can see that the minor axis lives on that line, and y equals -2, I can see the major axis lives on that line right there. And then I can see here, for example, the length, the semi-minor axis has a length of 2. So that was that 2 squared we had in the denominator. And then here we're going from 2 over to 7. So that's a distance of 5 for the semi-major axis. And we did have 5 squared in the bottom of the other. So that looks like we did have the right equation. Let's check it out for sure. X minus 2 squared divided by 25, or 5 squared, plus y plus 2 squared divided by 2 squared, or 4, has to equal 1. And I can see my purple ellipse sits right on top of the red one. There's the red original one, purple sits right on top. So we did well there. So that is the correct equation. We had to complete the square to make that happen.